In problem 6, we're told that in a state, um, because of rainstorm, the water stored in a reservoir increased from the capacity of 124 billion to 138 billion. And we are told that um, that the amount 138 billion equals 0.82% of the total capacity. And then we're asked to calculate the shortage of water from total capacity prior to the storm. So this is what we're trying to or going to figure out in this problem, assuming that X is the total capacity of the reservoir, and we calculate X and then subtract the amount of water, which is 124, which was the amount prior to the storm. So I've set up this equation. First thing I'm going to do is, of course, in order for me to calculate this amount, I need to calculate X. So I took this equation and moved 0.82 to the right, and I'm going to do a calculation here and find out X. So let's do that real quickly. I'm going to actually try to do it the old-fashioned way so you guys can follow me on how these things are done. Actually, before I start, go back here. Let's make this a little bit simpler. So it's 138, and I'm going to remove this decimal and multiply this thing by 100, which is same as this guy. And let's simplify this a little bit. If I divide 82 by 2, I get 41. Divide 138 by 2, I get 6 and 9. So this becomes 69 over 41 multiplied by 100. So let's calculate what is 69 divided by 41. So we get 1, and it's 828. We got a decimal here, and we have a 280. 41 by 6 is 246, and that equals 34, and I'll go ahead and add a 0 here. This is old-fashioned division. Multiply 41 by 8 will give me 328. Get 12 from there. Okay, so I think we have a reasonable number here that we can work with. So that will give us an approximate amount of total capacity, which is 168 billion. So now we know X, so all we gotta do is plug in X into this equation that will give us the answer. So that becomes 168 minus 124, sorry, which gives us 44. So the answer in this case is E.